all right. Welcome to one more session of the WOC. This is your Vani ma'am back again with the Trick 2 series in organic chemistry. All right. As a child, I remember always one thing. What is that? I used to pester my mom asking why. I used to pester my father asking how. I used to pester my sisters asking if I find out why, how, what next. This is what was Vani ma'am. Just like that, everyone should have that curiosity to learn. So, as we continue the journey of WOC, this is your Vani ma'am again greeting you all. Hello, Namaskaram, Vanakkam, Shastriyakal, Adabarse, Chennagidra, Bagunnara. Let us start with our session. Let us dive into the session 2, that is Trick 2 of your organic chemistry. Before I start and pick up my duster as well as my pens, let me greet all the students who were there with me, my gratitude, and all the students who are watching me for the first time. Hello, hello, hello. Let's start for your board examination. Trick 2. Let us go into the series and understand the concept. If you understand the concept, any question which is given to you, it is easy, damn easy for you. Basically, chemistry is easy peasy, students. Let's start. So, as you have seen on the board, I have written a question. Let us read the question. Let us understand the concept, and dhanadhan we are going to apply the concept in all the MCQs. Let's start. The question given to me is, predict the product formed when. Okay, they have given me one reactant. What is this reactant? When you see, it is 1,1-phenyl-ethene. So the reactant is given. It is reacting with halogen acids or HBr. So HBr, let it be HI, let it be HBr, not a problem. So it is reacting with an halogen halide rather. And what are the products formed? They have given me 3 options. First of all, you have to remember one concept. What is this? This is an alkene, right? So the concept is, whenever alkene is given to you or whether alkyne is given to you, remember, when somebody is asking you or giving you a compound or a particular reactant HBr or HI or HCl, remember, alkenes or alkynes, both one having the double bond, one having the triple bond, when they are reacting with HBr, they are going to undergo a particular type of reaction that is nothing but electrophilic addition reactions. I'll explain you what it is, why it is, and everything. So, concept number 1 to remember, electrophilic addition reactions. That is what alkenes or alkynes, by undergoing electrophilic addition reactions, they're going to form a compound called alkyl halides. Simple, correct? We are learning the chapter. Now, what is the concept? Let us take this. Hope you understand. Remember, this will be useful for your one of the MCQ. So, now the concept is what? Whenever I take alkenes, remember, so alkenes are how many varieties? There are 2 varieties. Symmetrical alkenes or unsymmetrical alkenes. Correct? Let it be alkynes. That means, first of all, I am taking the concept. When I have symmetrical alkene, what actually is alkene? We have studied in grade 10th also. Alkenes are double bonded, unsaturated compounds. See? Yes. Alkenes are of 2 types. What is that? Symmetrical and unsymmetrical. When you take symmetrical, how does it look? See here, one around the double bond, both the carbons are same. I am adding hydrogens, CH2, CH2. See here, when I break the double bond, both are similar, same number of carbon atoms. One more symmetrical, I am giving one double bond, one more carbon and one more carbon. Let us as hydrogens, CH3, CH3. Why CH3, ma'am? Around carbon, total number of valence is 4. So CH3, 4. Now for this carbon is 1, 2, 3, 4. So CH and CH. Now observe, in both the cases, symmetrical, equal number of carbon atoms on the double bond, equal number of carbon atoms around the double bond. Now, when you are adding, or in the exam, if they give you HBr addition, not a problem. Both the carbons are same. There is no confusion. There is no big mechanism. Both the carbons are same. Both the hydrogens are same. So, it adds directly to this here and here. There is no confusion. Directly this bond breaks. Hydrogen adds here, bromine adds here. There's only one product which is formed. I'm taking the top one. See here, this bond broke. This carbon, 4 carbons. One hydrogen adds here, one bromine adds here. The remaining hydrogens as you can add. So 1, 2, 3. So this is already there. 1, 2, 3. And this is the fourth one. 1, 2, 3. And this is the fourth one. Correct? So that means whenever you are taking symmetrical compound, symmetrical is a symmetrical, it is unsymmetrical. So symmetrical means only one product is what I get. That's clear. Now let's take an unsymmetrical and understand. Shall I erase this? Done. So symmetrical only one product. It is direct addition. There is no confusion at all. Correct? Where you'll break? You'll break where there's a double bond. Now the concept is unsymmetrical compound. So unsymmetrical means, let us take where around the double bond the number of carbon atoms are not similar. So I'm taking an unsymmetrical alkene. Just see whether did I take it right? Yes. Well, because around double bond, this side of the double bond, 2 carbon atoms are there. This side of the double bond, 1 carbon atom is there. Let me fill the hydrogens. 3 plus 1, 4, 2, 1, 2, 3. This is unsymmetrical, remember. So for unsymmetrical alkenes, two concepts I should remember. What is that? That is, when I am adding HBr, it is going to give me two products. What is that? HBr, two conditions, careful. It is going to follow two types of additions. One is a Mark rule or the Markovnikov rule. Mark rule. The second type of addition is anti-Markovnikov, means opposite to Mark. Anti-Mark rule, or it is also called as Karash effect. Karash, or it is also called as peroxide effect. Peroxide effect. Done. That's all. What is that? So whenever you have unsymmetrical, whenever you have hydrogen halide, either it falls Mark rule or anti-Mark. Nothing. I'll make it more simpler. So let us erase this. So what I'll do is, I'm going to take this, correct? So HBr, I'll use this place and this place. So HBr is there only. Now, HBr, suppose if it is getting added, the first rule I'm doing Mark addition. The second rule I'm going to do anti-Mark addition. So remember, Mark addition, you'll always get 2 marks only. What is that? Let us say Mark, how many marks? 2 marks. Anti-Mark, 1 mark. Shall we remember? What is that? Again, Mark addition 2 marks, anti-Mark addition 1 mark. Let's see what it is. So the Mark addition, remember, as soon as you add, there's a cleavage of the bond. The negative part goes and adds to the carbon having less number of hydrogens. Once again, the negative addendum goes and adds to the carbon having less number of hydrogens. Less hydrogens. Done? Yes. So positive part adds to the carbon having this. Mark addition, in which negative part goes and adds to the carbon having less number. So how does the product look? This way. So CH is here only, C, and Br and CH2H. Okay, done. What is this compound? This is 2-bromopropane. Correct? Yes. So that means, why did I say 2 marks? See here. What is this particular carbon? Secondary carbon. That means in Mark addition, I'll be getting secondary carbon compound. Secondary carbon. The bromine is going to attach to the secondary carbocation, or you'll be getting secondary carbon attached bromine atom or carbocation attached bromine atom. Now, in anti-Markovnikov, important thing you should remember, you'll be having a peroxide. Correct. Peroxide means, for example, benzoyl peroxide. See here, what is peroxide? Something which has OO bond is peroxide. This one. This is peroxide. So if you have peroxide, simple, do the opposite of that. Negative part goes and adds to the carbon having more number of hydrogens. This time, this goes and adds here. Now what will I get? I get CH3, CH, positive part here, negative part here. What is this compound? This is 1-bromopropane. Correct? Okay. Now carefully remember. What did I write now? Ma'am, all is confusing. What should I do? Remember one thing. I'll erase or write here. Careful. Mark addition or Markovnikov addition. Anti-Mark addition. What is the difference? Anti-Mark addition. In Mark, do we require unsymmetrical? Yes. Unsymmetrical alkene is required. Okay. Now in anti-Mark, do we require unsymmetrical? Yes. Here also unsymmetrical alkene is required. Correct? Over. In Markovnikov addition, do we require peroxide? No. No peroxide is required. No peroxide. No peroxide. In anti-Markovnikov, yes, peroxide. In the presence of peroxide only, the reaction occurs. Fourth, rather in Mark addition, what product you get? You always get two or secondary product. Secondary product is what you get. Secondary product. In anti-Markovnikov, you get primary product. Correct, no? Yes. Secondary product or primary product. That means here 2 bromopropane, here 1 bromopropane. Clear? So the secondary carbocation is what it is formed. Now the concept is clear. Let us understand. So noted everything. Let me take out the concept. I am clear. If I use Markovnikov addition, I get 2 marks. Secondary product. If I use anti-Markovnikov addition, I get 1 mark only. Done. Now let us solve this question. Concept is done. I am erasing this, or shall I write here? This part I will write and see. Now take that compound, elaborate it. See here, I am writing the same compound here. Take that, nothing, simple, easy peasy. It is like this, correct? Now this bond is attached to this carbon. There is a carbon here. Take this carbon, again write double bond, done. To that carbon there is hydrogen. To that particular carbon there is hydrogen, there's hydrogen. Easy, easy, simple. Now what are we adding? HBr is what we are adding. H plus Br minus. Now you only tell me here to this carbon how many hydrogens are there. Just take students, how many? To this carbon there are 2 hydrogens. Correct. To this carbon how many hydrogens are there? Only 1 hydrogen. Check here. To this carbon, if I see here, this is CH2. Now this is carbon. Okay, let us not make the difference. Just make carbon. Now see here, we'll think about this. Carbon has 1 hydrogen here. This carbon has 2 hydrogen. Is there any peroxide? There is no peroxide. It is Mark rule. So where will I go and do Mark addition? I am going to take the negative addendum adds to the carbon having less number of hydrogens. Simple. I am going to draw the particular molecule. Take this carbon. I'll write hydrogen. I'll write bromine. Single bond. C H H H. Over. Simple. Now what is this compound called? Just this is phenyl group, correct? So to this first carbon, because I added the negative part according to the alphabetical order, I have to name it. So it is 1 bromo, correct? So 1 bromo compound, basically alphabetical order halides. Then comes the next alphabet, this one. So 1 bromo, this is 1, correct? Then 1 phenyl. To this carbon, this is 2. This is 1 bromo, alphabetical order, 1 phenyl ethane, 2 carbons. The option is correct. Concept is clear. So simple thing to remember always. Mark I will get 2 carbon product or 2 marks. Anti-mark I will be getting 1 mark. Let us see one more question. Concept I will keep here. Remaining I will erase. Done. Next question. Let's start. Alright. Now with the concept, let us start the next question. So concept is clear. Let's see the question now. The question given to me is, this particular compound is given to me. No name, nothing, simple. But they have given me one concept here, that is when you are adding an hydrogen halide, that is Hi this time, what is the product form? What is X? That is what they've asked me. Nobody has asked me to label it. Nobody has asked me to give the UPSC nomenclature, nothing. I have to find what is the product. Clear? The concept, I am applying the concept now. So as soon as this question is given to you, what you should do, take the compound exactly like this, little bit elaborate the compound. Now, this is your CH3. Now, everywhere there are carbons, correct? So, this is 1 carbon, this is 1 double bond, this is 1 carbon, this is carbon, this is carbon, this is carbon, this is carbon. Now, to this carbon, count the valency. This carbon, 1, 2, 3, 4. There are no hydrogens here to this carbon because I have to do the electrophilic addition around the double bond. Now, come to this carbon. We are bothered about only this part, correct? So, to this carbon, 1, 2, 3. And the hydrogen. And this carbon CH2, this is CH2, this is CH2, this is CH2. Now our whole concentration should be where? The whole concentration should be here addition. Now add it to HI, H plus and I minus. Now see here, is there any peroxide? There is no peroxide. So the negative addendum goes and adds to the carbon having less number of hydrogens. Here, see here, this hydrogen is how many? H. There is 1 hydrogen, so my concept is wrong. Will it go? No, it will not go because this is Markovnikov addition. So according to this, I have to check the carbon having less number of hydrogens. This carbon has 1 hydrogen. This carbon has no hydrogens at all. So break the bond. I goes and adds to this carbon. Simple. So your bond is broken. So what do I get? I get a compound, that is this. which CH3 is here, and where did the I go? C is here only, and I went and attached. So which option is correct now? Option B is the right one. Concept is simple. Mark addition, Markovnikov rule, no problem at all. It goes and attaches to the carbon having less number of hydrogens. So this is Mark rule. Let us see the next question with the same concept. Alright, now let's do one more question. 2 questions are done. Now let's do the third and fourth simplest questions. Concept is the same, students, nothing to get confused. Let's read. The third question and fourth question. Here they've asked me, choose the correct product form during the conversion of alkene to alkyl halide. Okay. So basically, they've not given the product, they've given me 3 options here. First of all, I have to concentrate and I have to check whether it is unsymmetrical or not. Yes, it is unsymmetrical. Second, I have to see whether there is peroxide or not. Yes, there is a peroxide. I have to remember if it is peroxide, it is which rule? Anti-Markovnikov rule. Next important thing, if it is anti-Markovnikov rule, how many marks do we get? As just a clue, 1 mark. That is primary product. Simple, break this bond. The negative addendum, this also breaks. The negative addendum goes and adds to the carbon having more number of hydrogens. Simple, CH3, CH2, C, and the positive goes and adds here the carbon having less number of hydrogens. So hydrogen, single, CH2. That's what's the compound. Start numbering from here. This is 1, this is 2, this is 3, this is 4. Because alphabetical order, bromine comes first. So what is the compound we got? We got 1 bromobutane, which is a primary product. 1 mark. That's all. Now the C here, this compound. What is the product? Simple, plus, minus, break the bond. Now, is this Markovnikov rule or anti-Markovnikov? It is Mark addition because there is no peroxide. Mark rule. So now, according to Mark, the negative addendum goes and adds to the carbon having less number of hydrogens. I will be getting always secondary product H. This is Br. This is single bond. This is CH2. This is H. See here, what is this carbocation? Secondary carbocation. That's more stable than primary, correct? So what am I getting? Start numbering it. 1, 2. This should be 1. This should be 2, 3. Or 2 bromopropane. Correct? That's all. So this is 1 bromopropane. This is 2 bromopropane. Simple questions. Easy peasy. Next question. Alright, let us go and see the next question. Simpler question this is. Concept is the same, but simpler additions. Now they've asked me, predict the products formed. They have given me. Now what is this compound? Basically, a particular ring with 2 ethyl groups with a double bond. This is nothing but styrene, students. Styrene. Now you have to concentrate more on what? Your concentration should be on this double bond. Is it symmetrical or unsymmetrical? So basically, here there is no hydrogen halide, nothing. Concept is they've only given me bromine to attach. So what will I do? I will break this bond. I will break this bond. I will add the bromine. Simple as that. There is nothing, no logic, no magic. Simple. Take the styrene, take the styrene and make the bond here. The bond is here. So I'll try to add so that it will not confuse you all. Carbon, hydrogen is 1 on one side and bromine is on one side. Single bond. Hydrogen is here. Hydrogen, bromine. You can also write the compound like this. Same compound, you can write it as 1,2-dibromomethyl. What do you say? 1,2-dibromomethyl ethane? No. 1,2-dibromomethyl benzene? No. What is that? Can you all guess and tell me in the comment section what is that? 1,2-dibromomethyl benzene? Yeah. 1,2-dibromoethyl. Okay. Simple as that. It is 1,2-dibromomethyl benzene. Okay. Why ma'am 1,2-dibromo? 1,2-dibromomethyl benzene. Correct? So you can also write the compound as CHBr and CHBr. So I'm writing the compound as 1,2-dibromomethyl C6H6 na. So benzene. 1,2-dibromomethyl benzene. Simple. Easy. Let's see one more question. Alright, now let us see one more question. Very important concept here. So here what did they give me? They have asked me in the preparation of alkyl halide from alkenes, and halogen, which of the following reaction is involved? Whether it is electrophilic addition, whether it is electrophilic substitution, whether it is nucleophilic addition or nucleophilic substitution reactions. So first of all, students, I have to understand that in a particular unsymmetrical alkene, if we are adding hydrogen halide, whether it is bromine, whether it is iodine, or whether it is chlorine, you have to remember that it follows two types of mechanisms. One is Markovnikov addition, that is addition of HBr, whichever halide. Mark addition is one rule, and one more, in the presence of peroxide, it is going to fall anti-Mark addition. So during this process, what happens? When you are taking the main compound or the main alkene unsymmetrical, remember first there is a cleavage of the bond between HBr, and there is a cleavage of the bond of cleavage of double bond. Then hydrogen goes and attacks the carbon, right? Careful. It breaks the bond. When it is breaking the bond, it's going to pull the electron density from here to from the double bond to form a bond here. So when you're pulling the electron density, automatically there is a deficiency of electron cloud which is created, and it results in the formation of a carbocation. Correct? Careful again. Hydrogen, when it goes and attacks the double bond here, it drags the electron density during Mark addition such that there is a formation of electron deficiency where a secondary carbocation is formed. In the presence of anti-Markovnikov, when hydrogen goes and adds, it drags the electron density towards this side, and there is a formation of primary carbocation in case of anti-Mark. Now simple as that. Once the carbocation is formed, once hydrogen gets added, so which is getting added? Electrophile is getting added. This is your electrophile. So electrophile is getting added to this, forming a secondary carbocation. Now bromine goes and adds to this carbocation, giving us a stable product. So what is this compound? This is nothing but CH3. So this is 2-bromopropane. Correct? Right. So here in this case, bromine goes and attacks this, and I'm going to get 1-bromopropane. Correct na? Yes. So what is the concept? So during electrophilic addition reactions, there is addition of H plus. H plus is getting added. Because of that, such reactions are called electrophilic addition reactions. Simple, simple, easy peasy. So the concept of alkene or alkyne getting converted to alkyl halides clearly explained. I request all of you to like the video, watch the video completely, share the video. Your thumbs up, your likes matters a lot for WOC. WOC will not charge anything from you all students. Happy learning. Thank you so much. I'll meet you again with one more important concept. Bye-bye. Signing off.